In this video, we're going to be looking at finding the sine and cosine values for 0, pi over 2, pi, and 3 pi over 2. You probably noticed that because we don't have a degree measurement, we're working with radians. Okay? So, let's put up our Cartesian plane here. Okay? Here again's our x value, here's the y value. Now, 0 is the radian measurement that lies on the x-axis. Pi is 180 degrees, or on the other side of our x-axis. So pi is over here. Our other two are pi over 2 and 3 pi over 2. If you remember, after we complete one revolution, or 2 pi, we come back to 0. The values repeat again. Okay? Now, if you remember, these values were also, at the beginning of our chapter, it's something that we worked with a lot, the unit circle. Okay? Yep, I can hear the groans from some of you remembering it already. Now, what we need to do is, let's just recall a point on the terminal side of each of these measurements. Well, when we were working with the unit circle, r was always equal to 1. And if we were evaluating at 0, or 2 pi, we had the point 1, 0 in our favor. When we were working with pi over 2, we had the point 0, positive 1. When we were working with pi, the point was a negative 1, 0. And when we were working with 3 pi over 2, we had the point 0, negative 1. These were our x, y values. So let's take and continue with that. It's almost the unit circle. So, these are values that were commonplace when we were working with unit circles. So we can use them again because they exist when our radian measure is 0. Okay? Looking at the sine of 0. Sine of 0 again is always the rate sine theta, when theta is equal to 0, is our y value divided by the r value. Now, because we're using a unit circle, r is equal to 1. Okay? And our y value here is 0. So the sine of 0 is 0 over 1, which is equal to 0. Looking at the cosine at 0, cosine again was our x value divided by the r value. X being 1 divided by the r value of 1. 1 divided by 1 is 1. So the sine at 0 is 0, and the cosine at 0 is at positive 1. Let's look now to the sine of pi over 2. Sine at pi over 2 is always our y value, this time 1, divided by the r value, which is 1. 1 divided by 1 is 1. So the sine at pi over 2 is 1. The cosine at pi over 2 is our x value divided by the r value. X, we moved nowhere on the x, so we've got a value of 0, divided by the r value of 1. 0 divided by 1 is 0. So at pi over 2, we have sine values of positive 1 and a cosine value of 0. At pi, the sine of pi is equal to my y value, 0, divided by 1, which is 0. And cosine at pi is now a negative 1 divided by 1, which is negative 1. So here now we've reached our first negative values. At pi, cosine of pi is negative 1, whereas the sine of pi is 0. Finally, looking at the sine of 3 pi over 2. Well, sine of 3 pi over 2 is our y value, which is again negative 1, over the r value of 1. Negative 1 divided by 1 is negative 1. And the cosine of theta, when that theta is 3 pi over 2, is our x value. The x value is 0 divided by negative 1. There's 0 divided by 1, which is 0. So, looking at it, whenever you have a sine value of a -1, you have to be at 3 pi over 2. Whenever you have a cosine value of 0, you're either at 3 pi over 2 or pi over 2. Whenever the sine value is 0, you're either at 0 or pi. And if you have positive values of sine are given just at pi over 2. Cosine of 0 is a positive 1. And that's it. So, these are the 6 identities, or 6 common practice things. So when we're looking, make sure that you have those in mind.